Welcome back to the chapter Areas of Parallelograms and Triangles for Standard 9, and this is part 15. So continuing with the problems. This figure, it's given ABCD is a trapezium. ABCD is a trapezium. That means one of the sides are parallel. So AB is parallel to CD is given. So let us mark the parallel lines. And it is also given BE is parallel to AD. So BE is parallel to AD. So when you get the datas, please mark all the datas in the figure whichever possible, so that it is easy for us to identify the figures, the lines which are parallel, and accordingly write the triangles or parallelograms. And E is the midpoint of CD. So E is the midpoint of CD, that means these and this ED is equal to EC. Now we have to show that area of triangle ABF, F, I have forgotten to draw this figure. So ABF, this point is F, is equal to area of triangle BEC. So now, since these two are parallel, AB is parallel to CD, so it is parallel to DE also, and AD is parallel to BE. We can say ABED is a parallelogram. So the opposite pairs are parallel, so we can say the quadrilateral is a parallelogram. So AB is parallel to ED and AD is parallel to BE. It is given. Therefore, ABED is a parallelogram. Now consider this triangle ABF and this parallelogram. So they have the same base AB and they are between the vertex of triangle ABF. F is on this parallel. So that means the triangle lie between the parallels. So the area of triangle will be half of ABED. So area of triangle, because we have to prove area of triangle ABF and BEC. So first we will write ABF. So area of triangle ABF is equal to half of area of parallelogram ABED. You have to write the reason. Same base AB and between parallels AB and ED. This is a theorem that we have learned. Now we will consider this triangle BEC. So now again BEC also we have B and EC, they lie between the same parallels, and now we have learned that it should be the same base, but we have also learned a corollary for the same theorem that it can be either the same base or equal base. So DE is equal to EC. So we can say triangle BEC is half of area of the parallelogram ABED. So area of triangle BEC is equal to half of area of parallelogram ABED. The reason will be DE is equal to EC. So figures with the equal base so triangles we can write triangle and parallelogram with equal base and between the same parallels. Yes, AB and ED. So from these two you can say area of triangle ABF is equal to area of triangle BEC. So here it is given ABCD is a parallelogram and CE is equal to BC. So these two are equal. Now we have to prove area of triangle BDF. So we will join this. This is a diagonal. BD is a, so area of triangle BDF is 1/4 of area of ABCD. So now since BD is a diagonal, we can say area of triangle diagonal divides the parallelogram into two equal triangles. So area of triangle ABD is equal to area of triangle BCD is equal to half of area of parallelogram ABCD. So let this be equation 1. Now this AB and CD will be parallel. Because it is a parallelogram, the opposite sides are parallel and equal. So AB is parallel to CD, AB is parallel to CD and AB is equal to CD. So this is equation 2. Now here C is the midpoint of BE and CF is parallel to AB. So consider the triangle ABE, use the midpoint theorem. Midpoint theorem says if in a triangle the midpoint and the line passing through the midpoint is parallel to the third side, then this point will be the midpoint. So C is midpoint and CF is parallel to AB, then F will be the midpoint. So we can in triangle ABE we can say F is the midpoint of AE. Midpoint theorem. C is the midpoint and CF is parallel to AB. CF is the midpoint of this and FC is also equal to half of AB. So this is equal to half of AB can be written as half of CD. FC can be written as half of CD from 2. So then F is also the midpoint of CD. Therefore, we can say F is the midpoint of CD also. Yes. This is 3. Now consider the triangle. Now F is the midpoint of CD. So we will consider this triangle DBC. We have BDF is what we have to find. So we will consider the triangle DBC. again BF is the median in this triangle. BF, since F is the midpoint of CD, BF will become the median, and median divides the two triangles into equal parts. Therefore, area of triangle BDF is equal to half of area of triangle DBC. This is the theorem. Median divides the triangle into two equal parts. So now from this we can say BDF is equal to, now DBC is equal to, we have already done here. So we will substitute this here and you will get the answer. So this is equal to half into area of DBC is equal to, DBC or BCD is one and the same, into half into area of parallelogram ABCD. This is from 1. This is equal to 1 by 4 area of parallelogram ABCD. Area of triangle BDF is equal to, so we are using this midpoint theorem, and the median divides the triangle into two equal parts, and substitute and do, you will get it. So here in this question it is given PQRS is a square, this is a square, and N and M are the midpoints of S, R and RQ respectively. So these are the midpoints, and O is a point on the diagonal PR such that OP equal to OR. So these are equal. Now show that ONRM is a square, ONRM this is a square, and we have to find the area of, ratio of the area of triangle ORM, ORM and PQRS. So again it is given this O is the midpoint of this line and N is a midpoint. So immediately we can think of, since two midpoints we have got, we can consider the triangle SRP and use the midpoint theorem. So in triangle SRP, ON is parallel to PS and ON is equal to half of PS. The reason is N and O are midpoints, midpoint theorem. Now this is a square, PQRS is a square, so that means this angles are all angles are 90, so this will be 90, and therefore this angle is also going to be 90. So angle ONR, angle ONR is equal to 90. The reason is ON is parallel to PS and angle S is equal to 90. PQRS is a square. These are all data given. So now we have ON is equal to half of PS and PS and RQ are equal because it is a square. So we have PS is equal to RQ. So ON is equal to PS is equal to RQ. The reason is opposite sides, all sides are equal. All sides are equal in a square. Now ON is equal to half of PS, is equal to half of RQ, PS is equal to RQ. This is equal to half of RQ is RM. The reason is AM is the midpoint. So we got ON is parallel to PS and ON is equal to RM. So 1 and 2, ON is equal to RM and ON is parallel to PS. We can also write ON is parallel to PS, therefore ON is parallel to RQ. So we will write down here ON is parallel to PQ also. Not PQ, RQ, sorry. With this I have to write ON parallel to PS and ON is parallel to, therefore ON is parallel to RQ. So from 1 and 2, when you write down, you write it neatly. From 1 and 2 we can say, therefore ON, these are parallel and equal, therefore OMRN is a parallelogram. Now we have also written ONR is equal to 90 degrees and angle ONR is equal to 90. From 1, you already proved it. Therefore, one of the angle is 90 in a parallelogram, then it is a rectangle. Now we have to prove all the sides are equal. For a square, we have to prove it is a square. So now we have only proved the angles are 90. Now we have to prove all the sides are equal. For that we can say RM is equal to, RQ is equal to PQ. RQ is equal to PQ, and again O and M are the midpoints of these in this triangle. So OM is half of PQ, RQ is equal to PQ, and then in triangle RPQ, OM is equal to half, OM is parallel to PQ and OM is equal to half of PQ, midpoint theorem. Now OM is equal to, PQ is equal to, so this is equal to half of RQ. So we already got ON is equal to half of RQ. Now we got OM is equal to half of RQ. So from 2 and 3 we can say ON is equal to OM, and we also proved OM RN is a parallelogram and angle ONR is equal to 90 degrees. Therefore, OMRN is a square. Hope you understood. We have to simply use the midpoint theorem, prove ON is parallel to SP and half of SP. SP and RQ are equal, therefore ON is equal to RM, and it is also, this two are parallel, so this is parallel. So you can say ON RM is a parallelogram. Now since these two are parallel, you can say this is 90 degrees. So now we have to prove, since we have to prove it is a square, you have to prove all the four sides are equal. So for that again you can take this triangle, these two are again midpoints. So OM will be half of PQ and PQ and RM are equal. So with that you can prove all that this side is also equal to the adjacent side, and therefore since the adjacent sides are equal, then the parallelogram becomes a square. Now we have to prove you have to find the ratio of the areas of the triangle ORM and PQRS. So we can say area of triangle OR, area of triangle ORM is equal to half into area of triangle ONRM, because the diagonal divides the triangle, divides the parallelogram into two equal parts, two equal triangles. So ORM is equal to half of ONRM. Now ONRM can be written as half of RM squared, any side squared. So this is equal to RM, I can write this as half into half RQ the whole squared. So that is equal to 1 by 4, 1 by half into half, so 1 by 4, 1 by 8, 1 by 8 RQ squared. Now PQRS will be RQ squared. So now ratio area of triangle ORM by area of triangle PQRS of, not the triangle, the square PQRS is equal to, this is 1 by 8 RQ squared by PQRS is a square, so it is RQ squared. So that is equal to 1 by 8. Hope this is clear. I will see you with some more problems in my next video. So keep practicing and watching. Bye for now.